Okay, so this question, question 7, it's from 2017 paper, and it's obviously about assembly language. So normally on these questions, they do give you the assembly language reference sheet in the paper, and in this case they did as well. So you've got the assembly language to work with there, but it can look a bit daunting. But once we start to think about what we want to do, I think we'll probably see, hopefully, that it is not so bad. So it shows an incomplete assembly language program. Its intended purpose is to count from 1 to 10 inclusive, writing the values to memory location 17, and it says which is used to control a motor, which, you know, we don't really care too much about that, what it's controlling, but we're just going to write them to that memory location. So we've got some code already. So the first bit of code we've got is move. So we've got move R0 #1. So if we look across at where it says move, we've got move RD operand 2, and we're copying the value specified by operand 2 into the register D. So register we're looking for is R0. So if we write down R0 at this side, R0 is going to take the value of 1, because the hash there means that it's a direct number. So it's directly 1, not an address. So the value of 1 gets stored into register 0. So then we've got a label that's called start loop, which suggests to us that we're going to have a loop. And we've got another label down here called end loop. So these two labels inside here, we're going to have this loop idea. Excuse my wiggly line. So we've started the loop, or at least we've got a label for doing so. So the next command is str_R017. str is for store. So str RD memory reference, store the value that is in the register D, into the memory location. So if we've got location 17, and this is RAM, remember, then that's then going to take the value of 1 as well. So 1 has gone into memory location 17. So then we need a bit more code then to allow us to count up. So there's a few different ways of doing it, but probably the best way to do it is to use an add. So if we add R0 and R0, and what we want to add is a 1, because we want to add 1 more to it, because it says to count up from 1 to 10. So add R0 R0 1. So if we look at add, we've got RD RN, so 2 registers. Add the value specified in the operand to the value in the register N, that's this one, and store it in this register. So we're taking the value that's in R1, which currently is 1, and we're adding 1 to it, and so R0 register R0 becomes 2. So that's become 2. Then we want to decide, well, what do we want to do next? We want to loop really next, because we've added 1 to it, but we need to put a line in to decide whether we need to loop again or not. So that line is going to be a compare CMP. We're going to compare R0, so what's in register R0, with the number 11, because we want to count up to 10. So if we got to 11, then we're finished, so we don't want to go any further. And then we've done the comparing. So if this compares to 11, we want to do one thing. If it doesn't, branch if not equal to, branch if not equal to, and if we look at the branch condition here, we can branch to a label, and we can have equal to, not equal to, less than or greater than. So if branch if it's not equal to, and we're going to the label start loop. Start loop. So that means it's going to take us back up to here again. And that's essentially our code. So if we just step through that a bit to have a look what happens. So we've added 1 here and it's become 2 in register 0. So then we've compared register 0 with 11. Branch if not equal to, well, it's not equal to, so we're going back to start loop, and we're going to store what's in our 0 into 17. So the RAM location then takes the value of 2. We're going to add another 1 onto the register, that becomes 3. Compare again, well, it's not 11, so it's branch if not equal to, we're going back up here. 3 will go into the RAM, 4, etc., etc. 4 will go into the RAM here until we get to this figure being 11. When that figure's 11, we're going to be comparing R0 with 11. Branch if not equal to, well, it is equal to now, so we're ending the loop and halting, so we stop there. So we end up with the biggest number in RAM in location 17 being 10, because we never go back and add that extra 1 on. It doesn't get stored back into memory. So the register counts up all the way to 11, and then we stop. The RAM will count all the way up to 10, and then we'll stop there. And so that's the answer to that. There are more than one answer. You could do other answers to this. There are different ways of doing it, but I think this one's probably the easiest to understand.